Hello and welcome. In this video, we're going to dive into an important concept in statistics, the normal distribution. Also known as the Gaussian distribution, this bell-shaped curve is seen everywhere in real-world data. From IQ scores to stock prices, it plays a crucial role. Let's break it down. Now that we know what a normal distribution is, let's look at its key characteristics. This curve is perfectly symmetrical around the mean, meaning the left and right sides are mirror images. The mean, median, and mode are all the same. And most importantly, the shape of the curve is controlled by two parameters, the mean, mu, and standard deviation, sigma. Keep these in mind as we move forward. Alright, let's get a bit technical. The normal distribution is defined by a probability density function, or PDF. The formula might look complex, but all it does is describe the likelihood of different values occurring. The highest point of the curve is at the mean, and as we move away, probabilities decrease symmetrically. A special case of the normal distribution is the standard normal distribution. Here the mean is set to 0 and the standard deviation is 1. This makes calculations much easier, especially when using z-scores. Speaking of which, let's discuss that next. One of the most useful properties of the normal distribution is the empirical rule, also called the 68-95-99.7 rule. This means that about 68% of data falls within one standard deviation, 95% within two, and almost all, 99.7%, within three standard deviations. This helps us quickly estimate probabilities in real-world situations. Now, how do we measure how far a data point is from the mean? That's where the z-score comes in. The z-score tells us how many standard deviations a value is away from the mean. This is super useful when comparing different datasets with different scales. To make our lives easier, we use something called a z-table. This handy table gives cumulative probabilities, so instead of doing long calculations, we can just look up values. Let's apply what we've learned. Imagine student heights follow a normal distribution with a mean of 170 centimeters and a standard deviation of 10 centimeters. What's the probability of a student being taller than 180 centimeters? First, we calculate the z-score. 180 minus 170 divided by 10 equals 1. Then, using the z-table, we can determine the probability. Try it out yourself. The normal distribution isn't just theory, it's everywhere. It's used in stock market analysis, medical research, and even quality control. Whenever you see data forming a bell-shaped curve, chances are it follows a normal distribution. Let's wrap things up. The normal distribution is symmetric, bell-shaped, and defined by the mean and standard deviation. The empirical rule helps us understand data spread, and z-scores make comparisons easy. Before we go, here's something for you to explore. Look into skewness and kurtosis to see how distributions can be distorted. Also, check out other distributions like Poisson and binomial. Thanks for joining me. See you in the next lesson.